You've seen the headlines, the protests, and the political debates. But behind the noise, what is actually happening to our planet? Today, we strip away the rhetoric to look at the cold, hard data. We are going beyond the surface to reveal the true mechanics of climate change. To understand the present, we must understand the greenhouse effect. Imagine the Earth wrapped in a thermal blanket. Certain gases trap heat, keeping our world habitable. But what happens when that blanket becomes too thick? The balance shifts and the consequences are global. Carbon dioxide is the primary culprit. Since the Industrial Revolution, the concentration of CO2 in our atmosphere has skyrocketed. We are pumping billions of tons of it into the air every year. It's a chemical reality that science has tracked for decades with precision. While carbon gets the most attention, methane is a silent accelerator. It traps 80 times more heat than CO2 over a 20-year period. From industrial leaks to agricultural practices, methane is a potent driver that is often overlooked in the mainstream conversation. Global food production is a massive contributor. Industrial-scale farming releases significant amounts of nitrous oxide and methane. As the global population grows, the pressure on our land increases, creating a feedback loop that further warms the atmosphere. Forests are the lungs of our planet. When we clear-cut the Amazon or the ancient woods of the Pacific Northwest, we lose our best defense against carbon. Trees breathe in CO2. Without them, that carbon stays in our atmosphere, accelerating the heat. Our oceans absorb nearly a third of the CO2 we produce. This sounds like a good thing, but it's changing the chemistry of the water. Acidification is killing coral reefs and disrupting the entire marine food chain, which billions of people rely on for survival. Some argue that the sun is the cause. While solar cycles do influence Earth's temperature, the data shows that solar output has remained relatively steady, while global temperatures have surged. The sun is a factor, but isn't the primary driver of this trend. Over thousands of years, Earth's orbit changes, a process known as Milankovitch cycles. These shifts triggered past ice ages. However, these changes happen over millennia. What we are seeing now is happening in decades, far too fast for orbital mechanics to explain. Scientists look deep into the past by drilling into Antarctic ice. These ice cores contain tiny bubbles of ancient air. They show us that CO2 levels are higher now than they have been in at least 800,000 years. The evidence is frozen in time. Everything changed in the late 1700s. The invention of the steam engine marked the moment humanity began digging up carbon that had been buried for millions of years. We began burning coal, then oil, then gas, releasing ancient energy and ancient carbon. Here in the United States, we see the effects in real time. From intensifying hurricanes in the Gulf Coast to the record-breaking wildfires in California, the truth isn't just a statistic. It's a lived reality for millions of Americans every single year. In the north, the permafrost is melting. This frozen ground contains vast amounts of trapped organic matter. As it thaws, it rots, releasing even more methane and CO2. It is a feedback loop that could trigger warming beyond our control. As the Arctic warms, the temperature difference between the pole and the equator shrinks. This weakens the jet stream, causing it to meander. This is why we see polar vortices in Texas and heat waves in places that should be cool. Our cities make the problem worse. Asphalt and concrete absorb heat during the day and radiate at night. This urban heat island effect can make cities 10 degrees hotter than surrounding rural areas, placing a massive strain on the power grid. Plastic is a petroleum product. From its creation to its disposal, it emits greenhouse gases. Even as it sits in the ocean, sunlight causes plastic to break down and release methane and ethylene, adding to the global warming tally. The way we move matters. Airplanes, ships, and the millions of cars on American highways are responsible for a huge chunk of global emissions. While EV technology is growing, the transition is a race against a ticking atmospheric clock. Do volcanoes cause more CO2 than humans? The short answer is no. On average, human activities emit more than 60 times the amount of CO2 released by all the world's volcanoes combined in a single year. Nature is balanced. We are the thumb on the scale. The shift to renewables is no longer a dream. It's a necessity. Solar, wind, and nuclear energy provide a path forward. The technology exists to power our modern lives without destroying the thin layer of gas that keeps us alive. For decades, certain industries knew the truth. Internal documents show that major oil companies predicted global warming as early as the 1970s. Instead of acting, billions were spent on campaigns to sow doubt and protect short-term profits. International agreements like the Paris Accord aim to limit warming, but policy is only as strong as the nations that enforce it. Without the USA, China, and India working in unison, localized efforts are often overshadowed by global inaction. Should you feel guilty for using a plastic straw? Individual actions matter, but systemic change, how we generate electricity and move goods, is where the real battle is won. We need a total overhaul of our industrial infrastructure. Scientists fear tipping points, moments of no return. If the Amazon turns into a savanna or the Gulf Stream stops, the climate will shift into a new state that human civilization has never experienced. We are flirting with the edge. From carbon capture technology that sucks CO2 out of the sky to fusion energy that mimics the power of the stars, human ingenuity is our greatest asset. We have the tools. We just need the collective will to use them. The truth about climate change is that it is not caused by one single thing, but a symphony of human choices. The science is clear, the data is undeniable, and the time for debate is over. The only question left is, what will we do next? What if we could simply pull the carbon back out of the sky? Scientists are developing direct air capture, massive fans that chemically scrub CO2 from the atmosphere. While currently expensive and energy intensive, it represents a potential reset button for our atmospheric chemistry. If scaled globally, deep beneath the ocean floor lies a frozen form of methane called hydrates. As ocean temperatures rise, these fire ice deposits could destabilize. If they melt rapidly, they could release a massive pulse of greenhouse gas, acting like a clathrate gun that accelerates warming beyond human intervention. Paradoxically, some pollution actually cools the planet. Sulfate aerosols from burning coal reflect sunlight away from Earth, a phenomenon known as global dimming. As we clean up our air for health reasons, we may accidentally reveal the hidden warming that these particles were masking. The ground beneath our feet is a massive reservoir of carbon. Regenerative agriculture practices, like no-till farming and cover cropping, can turn vast American farmlands into giant sponges that soak up CO2. Restoring soil health isn't just about food. It's about climate stability. As the north warms, shrubs and trees are moving into the tundra. While more green might seem good, these darker plants absorb more sunlight than the white snow they replace. This changes the albedo of the region, causing the ground to absorb even more heat. Climate change isn't just an environmental issue, it's an economic one. In the USA, the cost of disaster relief, crop failures, and rising insurance premiums is already in the billions. By the end of the century, it could shave significant percentages off the global GDP. To reach net zero, many experts argue we need nuclear power. Unlike fossil fuels, nuclear plants provide massive amounts of baseload power without carbon emissions. The debate over its safety versus its climate benefits is one of the most critical discussions in modern energy policy. Our transition to electric vehicles requires massive amounts of lithium and cobalt. Mining these materials has its own environmental and human rights costs. The green revolution must find a way to source these minerals without repeating the mistakes of the fossil fuel era. The Amazon rainforest creates its own rain, but if enough of it is lost, the cycle breaks. The forest could transition into a dry savanna, releasing centuries of stored carbon back into the atmosphere and permanently altering the global climate. As sea levels rise and droughts intensify, people will move. We are already seeing the beginning of climate migration. Within decades, millions of people globally, including within the USA, may be forced to relocate, creating unprecedented social and political challenges. Can one person make a difference? While systemic change is vital, individual choices signal to markets and politicians what we value. From reducing meat consumption to choosing energy-efficient appliances, these actions aggregate into a powerful cultural shift. Artificial intelligence is our newest tool in this fight. AI models can predict weather patterns with pinpoint accuracy, optimize power grids to reduce waste, and even discover new materials for better batteries. Technology may have started this, but it might also help end it. Mangroves, salt marshes, and seagrasses are blue carbon powerhouses. They store carbon at rates far higher than terrestrial forests. Protecting our coastlines isn't just about stopping floods. It's about preserving these natural carbon vaults. This is a generation challenge. The decisions we make in the next decade will determine the world our children and grandchildren inherit. It is no longer a question of if climate change is happening, but how we choose to respond to the truth. The truth is revealed. The climate is changing and we are the cause, but we are also the solution. Stay informed, stay active, and join the conversation. The Earth is the only home we have. Let's protect it together.